You have lots of questions. One would hope that I have a few of the answers. What number? 51. Good news is this is the end of chapter 3. Bad news is, means there's a test coming up. 51, most of 51 is actually old stuff. It really is. So it's the spread of a rumor in a certain school. Now, when this textbook was written, Snapchat wasn't around. Facebook was still kind of in its infancy. It might only had a couple 100 million people on it. So the spread of a rumor is way quicker nowadays. I mean, how long does it take you to find something out about somebody? Not long. 2-3 minutes? I mean, it doesn't take long. So it's an outdated question. But this is actually what we call a logistics model of growth. But the spread of a rumor in a certain school is modeled by the following equation. Population as a function of time, meaning how many people know the rumor, is 300 over 1 plus 2 to the 4 minus t. Estimate the initial number of people who first heard the rumor. The idea here is, on part A, is this happens probably when time is 0. Would make sense to me. The very first people, maybe. All right, and if not, we'll have to do a little calculus, but this will probably give us the answer. So we have 300 over 1 plus 2 to the 4th, which I don't think is actually going to work. Let's do the 4th, 16? No, so this is actually 300 over 17. Actually, that'll give us the answer we're looking for. So these are the people that witnessed it, like Zach peed his pants. You can start that rumor if you want. About 18 people. This is people, you round up. No such thing as 6,400 of a person. Unless you wrote the U.S. Constitution. Then there is. So, about 18 people. They witnessed it. They started it. At least one of them has a smartphone. All right, so that's actually an old school question. Just have to think who was witnessing it. B is how fast is the rumor spreading after 4 days? How fast is rumor spreading? Now, that's not saying how many people know the rumor, is it? So you can't just plug in 4. That's talking about rates of change. You guys understand that? Which means we're talking about slope, which means we're talking about derivatives. That's all we're talking about slope, talking about derivatives. So we do have to take the derivative. That's what we're going to do. We're going to take our derivative. I wish I could write like a right-handed person. I don't know how y'all do it. How do you do it? Is it because, the book's not in your way? I don't know how you do it. I cannot write like a right-handed person with your hand down here. All right, let's take the derivative of 300 over 1 plus 2 to the 4 minus t. I would rather, I don't know if I want to do this or not. I think I do want to do this. I think I want to change it into a product of two things. Does it matter? No. I'll rewrite it. Although, is the quotient rule going to be that bad? Derivative of 300 is 0, isn't it? Quotient rule isn't going to be too bad either. So we'll just do the quotient rule. It won't be bad at all. We'd have 1 plus 2 to the 4 minus t. Then we take the derivative of 300 and what do we get? 0. So that's nice. Minus 300. And we do have to take the derivative of this function. So We're going to find the derivative of 1 plus 2 to the 4 minus t. Well, that's pretty easy. That 1 becomes 0. And what I'm doing is I'm thinking about a to the u. Thinking about a to the u. Because I have a base and an exponent. You guys get that? All right. So how do you find, in this case, the derivative with respect to t of some a to the u? A to the u, natural log a du. All right. So if we look at this example, a is 2 and u is 4 minus t. That's how things line up. A is the 2 and u is this exponent 4 minus t. So we would have 2 raised to the 4 minus t. Natural log of what? 2. And then we got to take the derivative of 4 minus t. What's the derivative of 4 minus t? What kind of 1? Negative 1. So here's my derivative, negative 2 to the 4 minus t, natural logs of 2. And that is all sitting over 1 plus 2 to the 4 minus t, all to the second power. Now, when you clean this thing up, you cannot multiply negative 300 and negative 2 together. Can't do it. Well, you can't do the 300 and the 2, let me say. The 2's got an exponent. The negatives do cancel. And I really don't see the point in trying to do anything special with it. So we have 300 natural logs of 2 times the 2 to the 4 minus the t, sitting over 1 plus 2 to the 4 minus t, all squared. That 2? Now the negatives cancel. There's probably something you can do with that thing to make it a little prettier, but it's an intermediate step. It's not even what the answer is. The thing is it says how fast is the rumor going after 4 days, right? So are we in a position to plug in a 4? Yeah. So we can plug our 4 in. It's probably easier to do this one on some of this on paper, or at least mentally in your head, as opposed to typing it all on a calculator, to be honest with you. So if you plug in your 4, these exponents disappear, don't they? This becomes a 2 to what power? 0. This is 2 to the 4 minus 4. It's just 2 to the 0. So this piece becomes a 1. That piece becomes a 1. And we'd have 300 natural logs of 2. And what would it actually be sitting over? A 4. It'd be sitting over 2 squared, which is 4. That's where I go to the calculator on that problem. Now, sometimes it pays to think mentally before you go to a calculator. Unless you happen to also know what the natural log of 2 times 300 is. If you do, you don't need me. About 52 people know that rumor. Now, what's part C? When will the rumor spread at its maximum rate? When will the rumor spread at its maximum rate? I'm going to look at the original function. If you got an older style calculator, you're going to have to use a whole lot more parentheses than that. Zoom 6 it. I'll have to go up quite a bit too. How many people are actually in this school? Probably 300. Y max to 300. It's starting to level off. They like to pretend that you know certain things here that you don't, which kind of stinks. When you talk about logistics models in a pre-calc class, if you manage to get to them, this is the carrying capacity where things start to level off. The maximum rate of increase happens halfway between where you level off and down here. And there's a shortcut to that, but I can't remember what it is, to be quite honest with you. And I was hoping we could look at the graph and figure that out, but you can't. So the graph of the main function, it tells me that it's somewhere in this region. That's where the slope's the steepest, right? You know, a rumor starts off slow, but as more and more people start knowing it, it spreads faster. And then eventually most people know it, so the rate of spread decreases. But we also have a perfectly good derivative function. Let's take a look at the derivative function. It'll tell us where it's highest at. I'll need a master set, 300 natural logs of 2, parentheses 2 rooftop 4 minus a t. That's all sitting over parentheses 1 plus 2 rooftop 4 minus t squared. I don't know if you actually needed the double set. You did need a double set of parentheses to keep that 1 plus 2 together. We'll take a look at that thing. See, that thing's telling us the actual rate of increase. That's the slope. It's the graph of the derivative. Later zoom 6 again. Now I know at 4 days, 52 people know this rumor. So I know I'm going to have to look up a little bit. You can kind of see that it peaked up top. All right, so let's set the X max up to around, I don't know, Y max up to around 60. See what happens. Now remember, this is a graph of the derivative. The y-axis is actually the slope, right? The y-axis is actually the slope. Happened right here. Now I have a graph in front of me, and I could use the graph to do it. I'm not going to. The whole reason I looked at the graph with y'all, I tried to do it the other way, the old-fashioned way, but it just wasn't going to work. The reason we looked at the graph here is because this is where the tangent line of the graph has a slope of what? 0. That's the concept here. Okay. So by hand, this happens when y prime is equal to 0. So we'll just take our little equation, our derivative, and we'll set it equals 0, and we're going to solve that thing by hand. That ought to be fun. 0 equals 300 natural logs of 2, parentheses 2 minus 4 to the t, sitting over 1 plus 2 to the 4 minus t, all squared. And I swear to you, it's not as bad as you think. It's really not. It's actually pretty easy to do. Just think about what you might do. What might you get rid of? How might you make it not fractional? It's the opposite of division, kids. So multiply both sides by what? That guy. You know what that's going to cause to happen. The left-hand side is still a what? Still a 0. start performing isolation techniques. There's a whole bunch of crap attached to that thing with a T. What do you do with that crap? You don't move it to the other side. You can't. There's no plus minus in between them. Divide. I don't know why I put that 2 up high. Divide both sides by 300 natural logs of 2. What's the left-hand side still? 0. Oh, we have quite a conundrum here. We really do have quite a conundrum here. We have a huge problem. It's impossible to answer. Why is that impossible to answer? Give me an exponent that'll make a 0. There isn't one. There is no exponent that turns something into 0. It does not exist. So that's why I said we have a bit of a problem there. It's one of those times that you just can't do something with algebra. It happens. It does. Not the end of the world. It's really not the end of the world. And yes, I did all that for nothing. I remember doing this one in the past. There was no point in doing it. Just to show you that sometimes you do algebra, there's nothing you can get out of it. We didn't make any mistakes in our process kits. We didn't do a single mistake. Not a one. You still had a perfectly good graph in front of you, didn't you? Now, how do you find that? Maximum. Second trace 4. So left, right, guess. It's going to be, oh, I did not do a second calc max. I did a intersect. Left, right, guess. 4 days. 52 people. In 4 days, the rumor is spreading at its fastest rate. So that was 10 minutes on that problem, maybe a little bit more than that. What else you got? What number? 42. Huh?
43.
43. Let's see here. We were just about to start this one. There's an example in your notes, x to the x, that I didn't get to finish. You know where I left off? That's called logarithmic differentiation. 43 is y equals sine of x to the x. Now, when you talk about a to the u, a is a number. You can't do a to the u here. A is a number. That's why you don't use it for that. And there's a reason they're calling it logarithmic differentiation, because what you're going to do is you're going to ln both sides. If something says logarithmic, natural log it. ln of y equals the natural log of the sine of x to the x. And you can start taking derivatives here. It's really not a problem. I promise you it's not. It's kind of like implicit differentiation. First, we'll clean it up a little bit. x natural logs of sine x. And now we'll do implicit differentiation. Implicit differentiation is when you take the derivative of something that's not x, but you say you did it. You know, what's the derivative of the natural log of y? You mean day 2 and you don't know your rules? No, it's not. It's not. Derivative with respect to x of the natural log of u is what? One over u du. So the derivative of the natural log of y is 1 over y dy dx, which is the goal here, find the derivative. So you got to say dy dx. All right, this little sucker right here, that looks like product rule all day long. Looks like it to me. By the way, the argument of natural log was sine of x, wasn't it? So it's product rule and chain rule. A little bit of both in it. Because you're going to take the derivative of that sine. It's part of it. All right, so that would be equal to x times the derivative of the natural log of sine x. And it's not really product and chain rule, but we're going to be able to take the derivative of this thing. Derivative of the natural log of something is 1 over something times the derivative of the stuff inside. What's the derivative of sine? Cosine. Cosine of x. That handles that piece. Plus natural log of sine of x times the derivative of x, which is what? 1. Okay. So let me do a little bit of a rewrite here. I'm not going to simplify everything. This is cosine over sine. That's cotangent x. Right? Is cosine over sine cotangent? So I have x cotangents of x plus the natural log of the sine of x. Now, you haven't actually written the derivative. You have a dyx, but you also still have a y in there. So I'll go back, I don't know, I think it was before Christmas when we did this. What is y? What is y? Look at the question. Literally look at number 40. Y is sine of x to the x, isn't it? So let's drop it back in here. 1 over sine of x to the x. I'm going to write y prime just because my handwriting's so bad. Equals x cotangents of x plus the natural log of the sine of x. Now, you'd have y prime if you just multiplied everything by what? Sine of x to the x. So here's your derivative. And I'm just going to wrap a set of parentheses around everything and not worry about it. I'm not going to distribute it in. Be done with it. There's your derivative, 43. What else you need to see? I guess I should give you all time. A lot to process. So that was what, 2 questions? Both from Julie? Oh, Riley had the first one. What else you need to see, kids? Only 2 questions out of that is pretty good. That's all you really truly have. Is that another one of those? No, 42 is a logarithm with a radical in it. You're supposed to find f prime and state its domain. I didn't actually go over domain yesterday. All right, so first off, I see a logarithm, which means that I have to know how to find the derivative of a logarithm. How did your book write this? Your book wrote this, derivative with respect to x of log base a of u. That was error rule. What is it? Yeah, 1 over ulna. That's how I remember it. 1 over ulna. And then du. And you'll hear that if you take calc class, your professor will probably say ulna. I don't know why, it just sticks easier that way. Du. And you just have to identify your u and your a values. I believe that's a, and this is u. All right. So let's talk about that. That's x plus 1 to the 1/2. You may as well find its derivative. You're going to need it. What is the derivative of x plus 1 to the 1/2? X plus 1 to what power? Negative 1/2. The odds of you taking a test and seeing that as an exponent are slim to none. You rewrite it as a radical. Negative exponent, when you shift it down low, the 1/2 is what power? Square root. So it's actually 1 over 2 roots of x plus 1. Now we just plug in our little formula, we'll be done with this thing. Might have to clean it up a little bit. All right, so f prime of x is going to be 1 over u, root of x plus 1. Natural logs of a, I'll wrap that in a set of parentheses. And a is 10, natural log of 10. Kind of surprised they put that 10 there. It should have been understood. And then I've got du attached to this thing, which is 1 over 2 roots of x plus 1, so just 2 roots of x plus 1 down low. That is the setup. I'm going to clean this up. I might go back and reference this line. What's the root of x plus 1 times root of x plus 1? It's x plus 1. And I have a natural log of 10. But we got kind of lucky here that the final product still has the same domain as the intermediate product. What's the rule that you can't, what's the one thing that you can't do, really, for the most part? You can't divide by 0. You can't divide by 0. So when you're doing domain, you always ask yourself what value of x generates a 0 where you shouldn't have 0.
Why does this set that 2?
Oh, I do need the 2, thank you. That's pretty important. Doesn't affect that anymore. Still the same x value. What value of x creates a 0? Negative 1. I know that x is not negative 1. Everything else works. Okay? Everything else works. Yeah, if you're going to write this out in interval notation, which I've got so many math classes mixed up in my head right now, I can't remember if pre-calc uses interval notation, or the calc book uses interval notation or not. But if you do, it'd be negative infinity to negative 1, union with negative 1 to infinity. It just says make sure you jump negative 1. Don't be it. A lot of times when you do a domain, you need to look at the initial setup as opposed to the final product. Thank you. See, that's kind of what I was getting at. This is conception. That's actually more important. If you try to throw a -2 at this thing from the very get-go, would it work? No, it would not work. If you try to throw a -1.1 at this thing from the very get-go, would it work? No. The initial setup is telling you that x is greater than or equal to -1. That is the one that matters. That is the one that matters. If you like that as interval, -1 to infinity. I know when I teach that in algebra 2, I always say look at that setup first. Otherwise, it's pointless. When you simplify things, you also take away what happened in the background too. You know, like you guys don't know it, but you know, when you first started growing, you looked a lot like a reptile. You had a tail and everything, didn't you? Yeah. The fetus looks pretty darn butt ugly for a while. It looks a lot like a little reptile. A lot of stuff that disappeared for the final product here. So it's the beginning that matters. I'm pretty sure you had a little itty bitty tail for a while. I might be making that up though, but everybody has tailbone. Some people are still born with their little tails. You know anybody who's got a little tail? I've only met one person who had a little tail. They had a little bone that protruded behind the tail. Crazy, huh? You can get it removed. They did not have theirs removed. And it still wiggled. Looking at me with amazement right now. Never heard of that? People are born with tails, yes. I'm almost certain that sometimes as a fetus that you have a tail. But people are born with tails.
I know you do, like when you're a fetus, how do you know you can be born with?
Yeah. We share 97, 98% of our DNA with reptiles. We're not all that much different. It's that little 2% though that makes us special. I don't know, what does Google say it? I'm almost certain I remember reading a long time ago in an actual book that people had tails when they were conceived. Then again, that would have been 25 years ago when I read that. So you are born, when you're conceived, you have a tail, right? And it usually does disappear. Hey, you learned something today. Of all the things you learned today, what did you learn? That you once had a tail. Why are you shocked by that? Look at everything else on this earth, with the exception of maybe some insects. But even insects have tails. They're just, they're long, extended abdomen for the most part. Doesn't everything have a tail? Birds have tails, tail feathers. Cats, dogs, frogs. Just about everything has a tail. And see, you start talking about your mammals, especially your mammals, cats, dogs, cows, horses. Horses don't really have a tail, but they have that little bone for their hair. If you had a tail, kids. Thus, you're supposedly either descended from or maybe genetic altercation of what, the chimpanzee? I say like genetic modification if you're one of those people who loves conspiracies and alien shows. There's no reason to believe that God didn't modify a chimpanzee to make us. God's an alien. What else you got? He's the definition of an alien, isn't he? Yes, he is. God is an alien. Remember, for all those of you who want to build a wall, you gonna keep pieces out? Of course, actually, he came down here in the flesh. Anyways, beyond random stuff, what else you need to know? Anything? Or are you just blown away by the tale? Have you been making this argument?
No, I didn't have lots of conspiracy.
Oh, I love that stuff. The angel drawing.
I don't believe in moonlight. I don't
That's
believe.
viable.
I believe we've been to the moon. I don't believe we went to the moon when they said we did.
The moon is an amazing thing. It is 1/400th the distance from here to the moon as it is from here to the sun. That is why you have a complete eclipse. You know what the odds of that actually happening are? Absolutely none. The surface of the moon, the powder that you see, is mostly titanium. What do we use titanium for? It's the strongest metal we can make. We use it in the aerospace industry. Yeah. All the large craters on the moon, the craters might be 10 miles wide, but they're all the same depth. Which means that the impact hit something even harder than the surface and stopped. They're all pretty much the same depth. They don't go down tremendously. They all just peak. Doesn't matter how many miles wide it is, they all go to the same depth and they stop. The moon is also too big for the Earth to catch the gravity. There's a lot of things about the moon that make it very special. If you like the conspiracies, which I love, you will read that people believe that it is actually what brought us here. Kind of interesting, isn't it? It's also one of those way, way out there things. And I love those way, way out there things. I do. There's a lot of crazy stuff about it. There's a lot of people who think the moon is not a natural thing. So if you're seeing that at home, there you go. There's your non-calculus lesson. And you all have tails. Are we done with math? I think we are done with math. We started talking about tails and the moon. Julie just believes that the moon landing was fake. I, however, don't buy into that one. I think the moon landing was videotaped.